Hey, what's up guys, my name is Cherno and welcome to the second episode of the Sparky game engine series in which we make a game engine from scratch in C++ and OpenGL. So, last episode we created this awesome window. If you want to catch up with the code or whatever, it'll be on GitHub. There'll be a link in the description to all of the source code. So you can either watch the first episode, which I recommend, or you can just download the source code. But the point is, this is where we stopped, right? We drew a rectangle. It was just a lovely white rectangle. We can resize the window, and it will appropriately resize. And we loaded in GLFW, which will be our OpenGL framework kind of library, which is just in charge of events such as lol. We're getting conflicts again. Lol. Anyway, which is going to be in charge of stuff like events, so keyboard events, mouse events, all that stuff, as well as actually giving us this wonderful window, which we created in the window CPP file, right? So that's what we did last episode. That's a quick recap. If you haven't watched it, go watch it. This episode, we're going to be loading GLEW. So GLEW, or OpenGL Extension Wrangler. In fact, I can just Google this because I'm going to have to download it anyway. Over here. It's over here, right? This is essentially needed for loading extensions. So the idea is Windows only gives us OpenGL 1.1, right? If we want to use a version above that, because clearly our graphics cards support versions above 1.1, you know, for example, my one supports 4.5. In order to use those later versions and all of the new functions that come with these later versions, we need to actually load them in because Windows doesn't do it for us. So we need something like this, which will simply load in the functions from our graphics card drivers and call them when we, so we need function pointers to OpenGL functions essentially. GLEW does just that, which is perfect because it would take it will take quite a while for us to write the equivalent, because literally all this library does is it literally just retrieves like function pointers to pretty much every OpenGL function there is, up to 4.5, which is awesome. So to get this, we're just going to use the precompiled binaries. So we'll get the binaries for Windows, which is awesome. Now this is available for Linux and Mac, I believe, but I don't think the binaries are available. Or at least, well, it wasn't on this front page, so it might be somewhere else. You might have to build it yourself. I don't know. We're on Windows, so we're getting that. Wait for this to download. And there we go. All right, cool. So here's the downloaded thing. Again, I'm going to take this. I'm going to put it into my libs folder. This is just for our extracted files. And now we've got GLEW in here. So in here, we've got a bunch of cool stuff. So we've got the lib that we want. If you go into release, I don't even know what release MX is, honestly, but under release and Win32 is what we want, all right? So, and we want the, so if you, again, I'm assuming that the S is the static library version. So if you want GLEW to get compiled into your, or linked into your exe file, you can use S. Otherwise, if you want to use a separate lib and DLL file, you can use the first one here, and then you can go back into bin, and you'll have to put GLEW32.dll into your actual directory for exe, right? We're probably going to do the former because honestly, we might as well compile or link GLEW into our exe. So all we'll need is this, right? So let's copy that. Let's take it into Visual Studio, Projects, and Sparky, and under Sparky we'll have dependencies, and then I'm going to make a folder called GLEW, all right? And under GLEW, we're going to make a folder called lib, so we'll be nice and organized, and then there's our lib file. And then we'll also make a folder, of course, called include, and then I'll go back to documents, into libs, GLEW, I'll grab the include folder, or rather, I'll just the GL folder inside it, and one more file, one more directory, and then I'll just paste it into here. So these are all the headers which we need, obviously, to actually call the functions. So that's where we're at. Let's party. So first of all, I'm going to right click on my project, hit properties, make sure I'm in the right configuration, so debug in this case. We could probably put this under all configurations as well. We'll leave it in debug for now though. In VC++ directories, I'm going to add the include directory, right? I'll add a new one being this GLEW include directory. Again, I'll make it relative to the solution. So we just need to change literally one letter there from F to E. Hit OK on that, and then library directories. I'm going to do a similar thing. Change that one letter from F to E. OK. And then all I need to do in the linker and input is add in glue32s.lib. So I'm guessing the S stands for static. Okay. So now, I mean, there's nothing to build, but hopefully we just don't get any errors flat out. Oh, we do. So can I open file glue32s.lib? Let's make sure that is in there. Lib, glue32s.lib. All right, let's just check that directory again. I think I didn't really pay too much attention to the directory. I just copied and pasted it. So let's make sure that our library directory is set correctly. Okay, it's not. So make sure let's remove this lib VC 2013 part of it. Hit OK, and now, fantastic, none of that. So I've probably somehow gotten, that's probably because glue was already, actually, okay, let's go back to fix this warning. Not that it's too deadly or anything, but we should fix it. It's conflicting with another library, so I've probably got something like, see, it doesn't look like I do though. We've probably got something in here that's being used. Oh, the MSVCRT one. So where else is this included in? So this is conflicting with another library of the same name, and I don't even know where, because the only ones we've changed, I believe, are, as in the only ones we've set are into our dependencies, right? What other library directories do we have? We don't have anything in additional. No, we don't. Okay, library path. That's weird. That is quite weird. So we've got, maybe both of these contain it. I don't know. Anyway, ignoring that, let's go ahead and, okay, so it builds and it opens up the file. So that's basically what we're interested in. You can find the library. So now let's actually instantiate this, or initialize it, I should say. In window.h, I gotta stop trying to do that because of the face cam, but I'll go ahead and include a gl/glue. So the good thing about this is this header file, if I actually go to it, open document, right? This is the actual header file, and it's massive. It's like 19,000 lines, and all of it is just like function pointers. And stuff like, constants, and all of those nice defines. But the point is, if you look at this, this is basically everything for OpenGL. In fact, I think it even has stuff like, so it even has like OpenGL 1.1 stuff, yeah, which gets defined and everything. So it's got everything we need. So we no longer need GLFW for that. In fact, it might even give us an error because something is included before it's supposed to be. We'll see. But that's really all we need. So once we've included glue into our window.h, we want to actually initialize glue. So glue needs to be initialized in a very limited. Let's just turn off all these IntelliSense errors. They're rubbish. What we need to do is initialize glue pretty much the exact same way that GLFW gets initialized. Now, of course, we want to check for an error and everything. So once we make our context, make sure you do this after a context exists. If you try and make this before you actually create the GLFW stuff, it's not going to work, okay? And you'll probably cry. So I'll probably demonstrate that in a minute, actually, not the crying part. But if we go ahead and say something like glue init, right? And the way we check an error code is essentially there's something called glue_OK. So if glue init doesn't equal glue OK, right? It means that glue is not okay and something went wrong. So we'll do our return false again, and we'll just print out something like could not initialize lol typing glue with a nice exclamation mark at the end there to let everyone know that I mean business. So okay, so see, for example, this gl.h was included before glue. Now, what included gl.h? That would have been included by GLFW. So let's just simply move these. If you hold down Alt and just the up arrow, you can move individual lines like that. Hit Control S and let's rebuild this again. And as you can see, we shouldn't get any errors, apart from unresolved externals, which is Fantastic. So looks like it can't load our library. Let's go back into this. All right, so this is defined. Okay, cool. We're in the header file. All right, time to investigate this library. Let's see. Library directories. Let's make sure that's correct. Lib, is that even right? Glue lib, it is. glue32s.lib. And I mean, surely it would have complained though. Let's try the other lib file. So let's try the other wonderful lib file that we've been supplied. Like this one. And see if that works. Maybe I was wrong about assuming that was. So let's just try this. Okay, that worked. I don't know. Maybe that's interesting. I would have liked to use the static one, unless I was wrong about it. I don't know. Don't know. So I guess we won't use the static one for now. I'll see if I can find a fix before next episode, but glue32.lib is what we'll include instead of glue32s.lib. So make sure you copy that. Make sure you copy that, just the without the s part, onto your lib directory so that you can actually open it. I'll keep the s in there for now. This unfortunately does mean we'll need the DLL file, unfortunately. So if I do build this, but I try and run it, it'll complain about glue32.dll is missing. So what you want to do is put that into the right directory. One thing I'm going to do today as well. Oh, I need the appropriate define. See, this is why live streaming is just fantastic. So let's go ahead and that's ridiculous. Okay, so let's try to change this to glue32s.lib, and then over in C++ preprocessor, I'm going to add a preprocessor definition called glue_static. Okay, so if I do that, let me just test out and make sure this works first. It works. Okay, cool. So that's great. Okay, so just to go into more detail, because I wanted to see if it worked first before I explain everything. So what I did was, so we're back to using our glue32s.lib, which means we do not need the DLL. So we're using s, and then over in C++ preprocessor, to use the static library, we need to actually define a little flag called glue static. Okay, and I'm assuming that will that'll change how that'll probably be something in the header file. Let's see if we can find it out of curiosity. Yeah, so you can see that if glue static is defined, it'll call extern, otherwise it'll call our little decal spec with DLL export, which will actually essentially require a DLL file. So that's the awesome idea. Okay, so if glue static is defined again, it will do that rather than this, which is good because we don't want it to we don't want it to export it to the DLL file because we don't want a DLL file. Cool. So with that said, we shouldn't need that DLL file at all. So if we run this now, we should get our window, and we shouldn't get any error messages being like glue could not be initialized. So now glue is running and everything is fantastic. Now, do we need to terminate glue? I don't know. I'm just going to ask you guys in the chat right now. I don't think we do. In fact, we can probably just check the header file. Is there anything here about terminate? No, not really. So unless it's called destroy or something, I'm just going to assume it doesn't exist. So that being said, we should now have OpenGL like modern version-y running. Okay, so let's see. So one thing I'll do in Windows is once all this stuff gets done. Oh, and let me quickly demonstrate the crying part that I was talking about. If we grab glue init and we put it up before we make the context and whatnot, glue will probably fail. And as you can see, it says could not initialize a glue. So make sure this is after we actually make this context. Otherwise, it will not work. All right, so back down you go. Cool. So let's quickly print out the version of OpenGL we're on. So I'll just print OpenGL, and then we did this last time, but I actually want to be continually printing this. So GL get string GL version. All right, so I'll just do this at the end. Not that it matters, it's just that if glue fails, I don't want to print out our OpenGL version, right? So we want to return false and not print this out, because that'll give the illusion that everything is good, but it's not. So OpenGL 4.5, great. That was the same without glue. So we need to actually test glue by running an OpenGL method that is above 1.1, which is like 95% of them. So let's go ahead and do that. What I'll do is I'll just do something like we'll make a VAO. This won't even render, but it'll be sufficient for our test. So if I gen vertex arrays, that's something in OpenGL 3.0. We'll probably want one, and of course this is not how you do it, lol. I'm thinking in like Java LWJGL land. So let's do that. Yeah, so we're generating a vertex array, and we'll get onto that stuff in the future, of course. It's way too early to talk about that. We'll bind this vertex array, and then we will, we won't do this. Lol, I tried to comment it out, but it didn't want to be. Okay, we'll just shut that off for now. And then all I'll do is I'll just GL like draw arrays. Lol, we'll draw 0. That would probably fail. But anyway, let's just try to do something like that. And if we run it, hopefully we get no errors. Okay, so there's no errors. It's running, it's drawing stuff. We don't even have any shaders, so it doesn't know what to draw. Anyway, it's just mayhem, but it works, and we're not getting any errors. So I think this is good enough to demonstrate that glue is loaded correctly. Because again, this stuff is modern OpenGL, which is in like OpenGL 3 and not in the default 1.1 that we get. So that being said, everything is just the best now. So we can probably, there was one thing I wanted to do in this episode that I thought, you know what, let's do that. But I don't remember what it was. Let's think. Did I mention anything, stream? Did I mention anything that I was like, I want to do this today because we got a bit of extra time or something? There was something. There was definitely something. But I don't remember what it was. So rescue me, stream. Let me just go through this code quickly. So nothing. That's all good. We had our stuff done. I honestly don't know. I think I've covered everything I wanted to cover. Yes, maybe. No? Okay, so I guess we're going to end the episode here. What we're going to do tomorrow, and this actually won't be tomorrow, but in the next few days, what we're going to do next episode, I should say, is probably move on to input. So we'll cover some GLFW input, so how we can handle inputs such as keyboard and mouse. We'll probably make a nice class for that as well. And apart from that, we'll go with the flow. So that's it. If you have any questions, as usual, just post them in the comments below. I'll try and get to them next episode. I'll probably just answer some just in the YouTube chat as well. And yeah, and we'll move on. So I'll commit this to, oh no, I've remembered what I wanted to do. Almost. Something, oh yeah, I wanted to set up our, yes, you guys are lucky because I just remembered this before I stopped the video. I wanted to set up a nice output directory because right now, if we look at this, oh, you guys are so lucky. Right now, if we look at this just like half of our intermediates go to like this debug directory, then our actual stuff goes into this debug directory, and it's just mayhem. So what I want to have is just a normal bin directory, which has all of our binaries out here. Okay, so to do that, right, I'll right click on Sparky core, hit properties. We'll go all the way into general, which is just at the top here under configuration properties. And then what we're going to be looking for is output directory and intermediate directory. So what we'll do is we'll, and what are you guys typing caps for? Oh, right. Anyway, so once we're in this general, we want to take a look at output directory and intermediate directory. Output directory will probably set equal to, so solution directory, which is going to be this, because it's the directory of this solution file that we have right, right here. We want to make a folder called bin, so we'll just type in bin, stands for binaries. Inside there, I'm going to put probably what we had before, which was configuration. So basically, I'll just put bin /configuration. So configuration is basically what you see up here. Debug, release, anything. we want to have that stuff there, okay? Intermediate directory, I want to put into essentially the same directory as this. So I want to put it into solution directory, bin, configuration, and then intermediates, just like that. Again, this is just my kind of preference. It doesn't matter what you guys decide to do, but it's really up to you, but we're going to do it this way. So yeah, so if we just hit OK on that and we try and build this, let me just see if we didn't get any. No, we didn't. So sometimes it'll hang on. Intermediate directory does not end with a trailing slash. So let's go back here and add a trailing slash just in case we decide to use it somewhere else. So if we hit OK and build that warning should go away. I did. We actually didn't get any warnings. So you can see that we've now got a bin folder with debug, and then intermediates are in there, and everything's good. And we don't need to have these disastrous, like these folders here everywhere. I don't like having that around, so I'm just going to do that. Okay, cool. So if we build this again or whatever, well, it's not going to build again because it's already built, but inside here is sparkycore.exe, which is our lovely thing. Cool. So what I'll do quickly is restore peace by just switching that back on so we actually do get something rendering. But that is pretty much it. So I'm just going to push this to GitHub. So any questions, leave them below. And the next episode we'll move on to input handling, and let's just see if we can move around that beautiful square of ours. Okay, or rectangle actually is what it is. Thanks for watching, and I'll see you guys next time. Goodbye. Vroom.